Building AI agents is one thing, however, it's a whole other story when you have to deploy those agents into real-life applications. If you want to learn how to deploy LangGraph AI agents using LangServe and AWS without having to rely on LangGraph's cloud services, then definitely keep on watching this tutorial. Hi everyone, my name is Lode and I'm on a journey of building my own AI startup called Parrot. Throughout my tutorials, I'll take you along as I discover new AI tools that I use to build solutions for clients. In this video, I will learn you how you can deploy LangGraph AI agents using LangServe and AWS. We will use the AI agent that I built in my previous tutorial, which you can find here or in the link below, and deploy that solution into an API that you can access from anywhere and use it in any type of front-end application that you want. So without further ado, let's dive right into it. So we will set up this project in Visual Studio Code. I've created already a new folder, and the first thing that I will do is creating a Python virtual environment to make sure that all our newly installed packages are contained. So to do so, you can run python-m virtual environment, and this will initiate a new virtual environment. We will activate it by running this piece of code, and then we need to install all our required packages. I already created a requirements file with all the required dependencies. So if you have your requirements.txt file, you can run pip install -r requirement. And this should then initiate the installation of all the required dependencies. Once everything is installed, the next thing that we will do is initiate our LangServe application. And we can do so by running LangChain app new in this directory. We can skip this step, and now as you can see, there are a couple of folders and files created automatically. The most important one will be located here in the app folder under the name server.py. Here we will add all the logic behind our AI agents. Okay, the next thing that we should do is adding all our packages to the Poetry installation manager, because LangServe is relying on Poetry to install all the required dependencies in the deployment later on. So to do this, we can run the command poetry add, and then we paste all the dependencies as we have listed them in the requirements file. So as you will see, running this will give a conflict in resolving the dependencies. And if you read through this issue log, now you will see that they advise to change our Python version to a version between 3.11 and 3.13. If you go to the PyProject file here, we can change this here. So we copy paste this dependency, and then we should run poetry update, which will update the Python version. And once that is done, we can rerun our poetry add command, and normally that should resolve our conflicts. Okay, so now everything is installed properly, and the next thing that we will do is actually building our AI agents. And to do so, as I already briefly mentioned before, we will use the server.py file. As you can see, it is blank now, but what I will do is I will copy paste the code of my previous AI agents that I explained extensively in my previous YouTube video and Medium articles. I will copy paste it here and adapt it in a way that we can deploy it using LangServe and AWS. So I will walk through the code very briefly, but if there's anything unclear, please check out my previous video or article, and that will help you understand the code better. So let's paste the code from my AI agent in here. That's great. The first lines of code are basically loading in all the required dependencies to run this AI agent. And then we need to define a API key, the Tavily API key. This is an API key that we use to do web searches. Then we initiate our Fast API app. Then we define a first route that redirects the base API to the docs pod, which then contains more information about the different routes that you can use in this API. The next lines of codes are an exact copy-paste of my previous tutorial, a brief recap what this AI agent does. So it is an agent that can be used on a website of a solar panel company, and basically it can provide information about solar panels, but it also asks the user to give them their monthly energy costs, and in that way the AI agent uses that energy cost to compute the potential savings of the customer if they would have solar panels. So it's a way of generating leads, because you can then extract information from the user and then contact them afterwards to buy the solar panels from your company. So basically this piece of code computes the potential energy savings based on the monthly cost of the user. Then we have two utility functions that handle any errors that happen with this tool. And the next code is defining our large language model using AWS Bedrock. We will use AWS on the one hand to call our large language models, which in our case is the Anthropic Claude 3 Sonnet model. But on the other hand, we will also use AWS to host our API. So we define a large language model, and we also define a assistant prompt. And in this assistant prompt, we mentioned that our AI should behave as a customer support assistant for Solar Panels Belgium, and their goal is to extract the monthly electricity cost of the user. Next, we also define the Tavily search tool, which is, as I mentioned before, used for web searching, so that any other question regarding solar panels can be answered without providing a knowledge database. Then we combine the assistant prompt with the large language model and the tools. The tools are defined here, so we have the Tavily search and the compute savings tool. And then we go ahead and define our graph, or the actual AI agent. So we initiate a state graph, and then we add our nodes. So in this setup, we have two nodes, an assistant node and a tools node. The tools node contains the two tools that we defined. The assistant node is basically always redirecting the user input to either keep on reiterating the conversation or redirecting to the web search or the compute savings tool. The edges make the links between the different nodes. So we have a start node that then is passed to the assistant node. And from the assistant node, we can go to one of our tools. And then from our tools, we are back redirected to the assistant, so that actually the conversation keeps on being in a loop where users can keep on asking questions. We also define memory here, and then finally also compile the graph. So that was basically the code that I copy-pasted from my previous work. The next lines of codes are used to integrate this into an API. More specifically, an API that is produced by using LangServe, which is also built by LangChain. So they provide a full framework of hosting your chatbot or agent in the cloud. And the first thing that we do here is defining the structure of the API request. So basically, we want to have as an input of our API request a body with a JSON format where we have our input question, so the question from the user, and a thread ID. And this thread ID is used for memory. So if we have a conversation with user A, we will always use the same thread ID so that the AI agent knows the history of the conversation and can anticipate based on that history. How you define the thread IDs will be something that you do in your front-end application, and then you provide it to the API so that the AI agent always knows the history of the conversation. And then in the next piece of code, we define a new route, the generate route, which will be the route that we use mainly to interact with our AI agents. So it takes as an input a request in our format that we defined here. So we print a request here to see whether the input into our API is still valid. Then we define the state. The state has a specific structure where we have a dictionary with a list of messages that either is originating from the human, the user, or from the AI system. So in order to provide information about who is providing this information, we have this class human message that we can use. It's also provided by LangChain. And then as content, we give this the request.question. So the API will have a JSON structure that contains the question and the thread ID, and then it will extract here the question and have this as a human message in our state model. Then we also provide a configuration, and in this configuration we basically define the thread ID, which we again extract from our request. Next up we have this try except loop, where we actually call our graph or our AI agent using the state that we defined here and the configuration that was defined here. So this will create a stream of outputs, and for each output we will extract a key and a value and append it to this outputs dictionary, which will then be the actual output of our API. As you can see, there are a couple of print statements here. They are mainly used for debugging. I will show you in a minute how we can run this AI agent, and then you will also be able to see this outputs. In case there goes anything wrong within the code, we return an exception. And that is actually already the last piece of code that we have for this AI agent. So the next thing that we can do is actually go ahead and try out this AI agent. So first of all, you need to make sure that you have Docker up and running. This is required for running LangServe. And then you can run the command LangChain and LangServe. This will allow you to go to this local host URL where you are redirected to the docs page. And here you can see the generate route that we defined. And what is really convenient is on this page you can try out this API. You can do this by clicking on try out. And then here, as you can see, this is the JSON input structure that we defined in our code. So we have the question and the thread ID. So for example, we can ask the question, what are solar panels? Then we submit. It will execute our question. And if we go back to Visual Studio Code, we can see the print statements. So there was a point where we printed our question, which you can see that it's correctly in the request. And then we have our output, which contains the AI message, so the response, which is then reformatted to the dictionary with the messages. And if we go back to the URL, you can see that we actually get the response in the structure that we defined. So the results with then the dictionary with the different keys and values. And here then in the content key, we get the response: solar panels are devices that convert sunlight, etc., etc. I also want to show you that the memory does actually work by sending two messages to the AI agent. So first message will be I am Lore. We will still use thread ID 0. Now we get just a reply, thanks for letting me know your name is Lore. And then we will submit another question asking what my name is. So if the memory works, the AI agent should know that my name is Lore. And indeed, he does know that my name is Lore. So in this part, we set up our LangServe application and we've tested it and validated it locally that it is working properly. The next step now is taking this local hosted API and deploy it on AWS so that we can have this publicly available API that we then can integrate into any kind of front-end application that we want. So for this, we will use AWS Copilot. You can, of course, pick any other platform you want. There is documentation as well for Google Cloud. However, I like to use AWS just because I also use AWS Bedrock for the large language models, and I really like to keep everything in one cloud provider. But it's totally up to you, of course. So I will shut down the LangServe application for now. Okay, so before we can actually initiate our AWS deployment, you need to make sure that you have your AWS credentials active on your local laptop. And you can find back in the AWS documentation how you can generate your access keys and have them configured on your local laptop. But basically, you need to make sure that you have a configuration and a credential file in your home directory. So for example, I can show you where mine is located. So in my home directory, I have a directory .aws, and as you can see here, I have a configuration file and a credential file. So if you have this, you should be good to go to run everything related to AWS, both the Bedrock large language models as well as the AWS Copilot, which I will demonstrate now. If we take a look at the documentation of LangServe, you will see that there is a part deployment where you have different options to deploy your workflow. So you can deploy it to AWS, as I mentioned, but also Azure and Google Cloud. Also, LangChain is providing their own cloud hosting solution, LangCloud, which is a paid service and at this moment not available for everyone. Most likely that will be even more convenient to host something in the cloud. However, I suppose that will come with an additional cost, but I don't have experience with LangCloud myself, so I can't provide you with any details about that. Okay, we can go ahead and copy this comment. So if we go back to our Visual Studio Code and paste it in here, you can see that this command initiates Copilot, which is actually a service that makes it easy to deploy applications on AWS. So you can think of it a bit as infrastructure as a code. Instead of having to set up all these different AWS services separately, this Copilot helps you to automate a lot of things by booting all the necessary services and policies at once. So basically what we will do is we will boot a load balancing web service that then hosts our API. As you can see here, we have to give it an application name. I will call it AI agent. We also need to provide a service name, but I will also just name it AI agent. Then type, we want it to be a load balanced web service. The Docker file is in here. As you can see, this is provided by LangServe. And we also add the deploy parameter so that it automatically deploys the application. And actually, before initiating this command, I want to make sure that I'm in the right AWS region because I usually use the US East 1 region since most large language models are available there. So also for deploying my application, I will switch to the US East 1 region. We can do this by running export AWS_region equals US East 1. And now we can finally go ahead and run the command. It will now set up the load balanced web services. And this might take a couple of minutes, so be right back. After a couple of seconds, we get the question, what is your environment's name? This is convenient if you want to have like a development environment and a production environment separately. I will now call this environment dev from development, and then it will initialize this development environment. And if you in future want to switch to a production environment, you can just create a new environment here and redeploy it in that environment. Okay, this will again take a while to initiate everything, so I'll see you back in a couple of minutes. Okay, unfortunately there was an issue during the deployment, and to check out what the issue is, you can run the command Copilot CVS logs. This can only be done as long as the resource is active. Otherwise, you will need to go into the AWS console and check out the CloudFormation logs. But if you're running this command during the rollback of your services, you should be able to see the log. And we can see here that there is actually an issue with the Tavily API key that we have provided. Because indeed we need to specify this environment variable in our manifest, in our Copilot manifest, which you can find here. If you go to the Copilot folder, then AI agent manifest, we can provide here our variables. So here you can paste in your actual API key, then save this. And since we're here, I realized that there are two other settings that we need to modify. First of all, there is this health check that is commented out, which we will uncomment. We will also change the path to docs. And secondly, we need to fix some permissions. So basically our AWS application needs access to the large language models that are available in AWS Bedrock. So we need to provide it with a policy to grant these permissions. And to do this, you can go into the Copilot folder, then in AI agent, and then create a new folder named add-ons. In this add-ons folder, we will create a new file called bedrock-policy.yaml. And in this YAML file, we will paste the policy that grants access to the Bedrock large language models, like this. And here you can see that we give access to a set of large language models that are available via AWS Bedrock. Okay, now we can save the file and redeploy the application. And actually, instead of running the previous command, we can just run Copilot deploy, because the previous command did the initiation of our application, which is already done. As you can see here, everything is initiated. So when we run the Copilot deploy, it will deploy everything to the development environment. And again, we will have to wait a couple of minutes, but hopefully the issue that we had should be resolved. Okay, great news. Everything was deployed successfully. We now receive a URL, which is our actual API that we can use in the same way as we did before when testing the localhost URL. So if we click on this, we will be redirected to, again, the fast API page. And then we can again test the generate route here. So for example, we can again ask, what is a solar panel? And indeed, as you can see here, we get an answer to our question. So that is great. We now have an API that we can introduce in whatever kind of application that we want. And that brings me to the end of this tutorial. So in this video, we have learned how to deploy any kind of AI agent using LangGraph, LangServe, and AWS Copilot. As always, if you have any thoughts or questions, please feel free to leave them in the comments below. Also, if you like this video, then definitely like, subscribe for more of this kind of content. You can also find more videos on my channel and detailed tutorials on my Medium profile. And with that being said, I hope to see you in my next video. Bye!